Hello and welcome to the penultimate video in C6 Chemistry Out There. This is on fats and oils and my name is Mr. Clee. Right, the aim of this video is that by the end of watching it you should be able to describe the properties and uses of fats and oils, including saturated and unsaturated fats. We should be able to explain how fats are made, what their structure is, looking at the difference between two types of emulsions, oil in water emulsions and water in oil emulsions. And we should also be able to explain how margarine is made and soap is made. Right, the basic distinction between a fat and an oil is that a fat is a solid and is an animal fat, and an oil is a liquid and tends to come from a plant. The structures, the reason that the difference is to do with density. Fats are more dense, they tend to be majority saturated fats, whereas oils are less dense, they tend to be unsaturated fats. As well as cooking and all that sort of stuff, the main things that potentially we can use oils for is it's important in the chemical industry. It's also a potential fuel, a biofuel, including biodiesel, which is made from rapeseed oil, and it is also used to make soap. Right, there's a link back here to C1. Fats are basically esters. So esters, if you remember, are formed when alcohols and acids react together. When alcohols and acids react together, they form esters and water. So when fats are made, which is basically our ester, it requires an alcohol, which is always glycerol. The reason it's glycerol is because glycerol has 3 OH groups, and it's also an acid. These acids are called fatty acids, and it's the fatty acids that react with the glycerol to make fat or oil and water. So here you have some examples. This is the glycerol, and if you notice it's the 3 OH groups that are important, because that means that 3 fatty acids can bind to the glycerol. The fatty acid, again, it's the OH group that's the important one, which binds to the OH group of the glycerol, creating what's called our triglyceride. We basically have our glycerol molecule and then our 3 fatty acids coming off in long chains off them. So in this topic we also need to touch back onto emulsions. Emulsions happen when you get oil and water mixed. As you know, oil and water are immiscible. That means that they do not mix with each other, they do not dissolve. You end up with a layer of oil forming on top of a layer of water. The reason for that is that the oil is less dense than the water. However, if you mix these guys together, then you can form an emulsion. This is when you get tiny droplets of one of the liquids dispersed into the other one. So here you have the layers of oil and the layers of water, and here you have the two mixed together in an emulsion. This emulsion will separate out again unless an emulsifier is used. Emulsifiers are molecules like soaps that have a hydrophilic and a hydrophobic end. A really typical one is lecithin, which is one of the chemicals found in egg yolk. You can also use mustard powder, English mustard as well, which has a hydrophilic and a hydrophobic end. Essentially what happens is you have the head, the hydrophilic head, which sits in water, and the tails, which are the hydrophobic, which sit in the oils, and it binds, holding the oil and the water together. So the extension to that idea is that you have 2 types of emulsions. You've got an oil in water emulsion and a water in oil emulsion. And as the name suggests, oil in water are majority water-based, and water in oil majority oil-based. Oil in water emulsions are used to thicken water-based stuff, and water in oil emulsions are used to thin oil-based things. Here's a couple of diagrams that show those. Here you have milk. Milk is your example of your oil in water. You can see the little droplets of oil dispersed through the water, and here is your water in oil, and you can see your little drops of water dispersed through your oil. A good example of water in oil emulsion is margarine. It needs to be soft enough so it can spread from the fridge, but not so soft that it runs. So there is a little bit of water in this emulsion with the margarine, and that's one of the reasons it's thin. But also one of the reasons that it's thick is because it's made using vegetable oils, which come as liquids and have to be solidified. And the way that they're solidified is by taking an unsaturated double carbon bond and turning it into a saturated, or increasing the levels of saturation within it. And the effect of that is to increase the density of the fat and make it more likely to be a solid. This is how that's done. You take your unsaturated hydrocarbon here and your hydrogen, you react those together. That splits the double bond that was in this position, creating a saturated hydrocarbon here. This is the hydrogenation of unsaturated fats, and it requires a catalyst, and you should hopefully know the catalyst by now because we've covered it a couple of times. It keeps coming up whenever we do about catalysts, and the catalyst involved in this situation is nickel. The last idea is in this topic is saponification. So soaps are made when oils or fats are split with hot sodium hydroxide. What you end up with is a molecule a lot like an emulsifier. You end up with a long fatty acid chain and a hydrophilic part, which is usually a sodium ion. The sodium ion dissolves easily in water, and the hydrophilic long chain oil sits well with fat. So soaps work because they are essentially emulsifiers, grabbing onto the fats, helping it mix with the water that you use to clean your hands, and helping you remove oil from your skin. So the process's name is called saponification, using sodium hydroxide to split natural fats and oils into the long chain fatty acids and back into glycerol. Here is the hydrophilic head. You can see the sodium ion that dissolves within the water and the long chain hydrophobic tail. This is sodium stearate, which is a very common fat, very common soap. Sorry. A lot of oils are made out of, and a lot of fats are made out of stearic acid, and this is the stearic acid bit that's the stearate that's bonded to the sodium that makes this soap. The word equation for that process is quite straightforward. It's just fat plus sodium hydroxide gives you soap and glycerol. In effect, you're almost reversing the process that caused the formation of fat in the first place. So, in summary, oils are liquid, fats are solid. They can both be used to make biodiesel and soaps. Fats are examples of esters that are made from glycerol and long-chain fatty acids. Water is a byproduct of that reaction. Oil in water emulsions have tiny drops of oil suspended in water, and water in oil emulsions are the opposite. Margarine is a water in oil emulsion made from hydrogenated vegetable oils, which uses the nickel catalyst, and fats are turned into soaps in a saponification reaction with strong alkali such as sodium hydroxide. Thank you very much for watching. That is the penultimate video in this series. The next one is on detergents and will follow soon.